Good morning everyone. Myself LAXMI PRASANTHI. I am your chemistry teacher. In this video, I am going to explain about the boron molecular orbital diagram. In my previous videos, I explained the molecular orbital diagrams of hydrogen molecule, helium molecule, and lithium molecule, and beryllium molecule. Now coming towards the boron molecule. If we see in my videos, it is already explained clearly. Once again, for this molecule, I will discuss clearly. To write the molecular orbital diagram of any molecule, we have to write the atomic number first of all. Okay, what is the atomic number of boron atom? 5. Then we have to write the electronic configuration. 1s2, 2s2, 2p1 for 5 atomic number and then the electronic configuration. Then representation of the electrons in shell in boxes. 1s2, 2s2, 2p. P means in p orbital we are having 3 shells. They are based on the axis px orbital, px, py and pz in 3 axes. Okay, now the electron present in any one of the orbital. Okay, it is no need to place in x or y or z. Just for representation, just for writing, I written here px, py, pz. But the electron can place in any axis. Okay, but in p orbital. So after writing the electronic configuration in boxes, first we have to write the molecular orbital diagrams of all these atomic orbitals. Okay, now 1s orbital, 1s atomic orbital. In boron we are having 1s2 atomic in 1s atomic orbital we are having 2 electrons. So 2 boron atoms, atomic orbitals of 1s orbital, 2 electrons and 2 electrons. How many atomic orbitals are combined? That many number of molecular orbitals will be formed. So 2 molecular orbitals are formed here. One is bonding molecular orbital, another one is anti-bonding molecular orbital. Totally 4 electrons. That's why 2 electrons are placed in bonding molecular orbital, another 2 electrons are placed in anti-bonding molecular orbital. So this one is sigma 1s orbital. How many electrons are present there? 2 electrons. That's why sigma 1s square. Anti-bonding sigma 1s, that is sigma star 1s. How many electrons? 2 electrons. So sigma star 1s square. Now coming to, we have to write the molecular orbital diagram for 2s atomic orbital. Okay. In 2s atomic orbitals also we are having 2 electrons. So 2 orbitals are combining, 2 molecular orbitals will be formed. One is bonding and then one is anti-bonding. Again we are having 4 electrons. So we will distribute these 4 electrons in bonding and anti-bonding, 2 electrons each. Now coming to the electronic configuration, this is sigma 2s. How many electrons? 2 electrons are so sigma 2s square. In anti-bonding means sigma star 2s. How many electrons? 2 electrons. So sigma star 2s square. Okay. Next coming towards the 2p atomic orbital. In p orbital we are having 3 shells, that is based on the axis px, py, pz. So in these 3 orbitals we are having equal energies, atomic orbitals. So they are, we can call them as degenerate orbitals. Degenerate means which is having equal energy. Okay, the orbitals are having equal energy, we can call them as degenerate. But when these 2 atomic orbitals are combining, then they have to form the molecular orbitals. How many atomic orbitals are combining here? 3. So how many molecular orbitals it should form? 6 molecular orbitals should be formed. 3 atomic orbitals, 3 atomic orbitals. So 6 molecular orbitals should be formed. So, but here while splitting or writing these 6 molecular orbitals, the energy levels will be differ. Energy levels may differ. How? That means sigma pz. Here z axis. The electron placed in in any one axis should combine or should form a sigma bond. Okay, the electrons present in another two axes or should form pi bond. Okay, so PZ, sigma bond formation. From basically we learned that always PZ orbital will form the sigma bond and PX, PY will form the pi bonds. So here pi bond less energy, then sigma bond, then goes towards pi, after that sigma bond. Okay. Now how many electrons we are having? 2 electrons. So here these two orbitals are equal energy. So first we have to write one electron in each shell. Okay. 2 electrons are over. There is no more electrons. So there is no need to fill the other orbital. Okay. I think it is clear. Now write the electronic configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next pi 2px, same level, that's why we have to put the equal to symbol, pi 2py. How many electrons are present here? 1 electron. Okay, when compared to 1s, sigma star 1s is having more energy. When compared to 1s, sigma star 1s, sigma 2s will have more energy. When compared to sigma 2s, sigma star 2s will have more energy. When compared to sigma star 2s, pi 2px and 2py will have more energy. But when coming to this, both are having equal energy. Okay, this is the way we have to write the electronic configuration. Then coming to bond order, half into number of bonding electrons minus number of anti-bonding electrons. How many bonding electrons? 2 plus 2, 4 plus 2, 6 bonding electrons minus anti-bonding, 2 plus 2, 4. There is no other electrons. So 6 minus 4. So half into 2, 1. So how many bonds will be present between two boron atoms? 1 bond is present between the two boron atoms. Now coming towards the magnetic nature. What is the magnetic nature? What I said to you, in any one molecular orbital, if it is singly occupied, then we can call that molecule as paramagnetic. If all the molecular orbitals are doubly occupied, then it is diamagnetic. Here doubly occupied, here also in paired condition, but here it is singly occupied, unpaired electrons. So it is paramagnetic. Why it is paramagnetic nature? Because of the presence of unpaired electrons in its where it is present. Unpaired electrons present in its molecular orbitals. I think it is clear. Once go through it and note down. In my next video, I will come forward to you with another molecule orbital diagram. Okay, thank you.